Hi everybody, so we started talking about right triangle trig, and now we have to talk about when we use right triangle trig with word problems. So in order to use if we want to use trig in a word problem, obviously we have to have a focal or central angle to focus on. So that's where the words angle of elevation and angle of depression come from. So if you go ahead and highlight your title, okay? And then I want you to highlight where it says what is angle of elevation and what is angle of depression. Okay. So angle of elevation is the angle that the ground makes when you look up. So the angle of elevation is always from the ground up. Always from the ground up. Okay. The angle of elevation is always measured from the ground up. So when you're looking up at a building or you're looking up at a tree, angle of elevation is always measured from the ground up. Notice it's this variable x right there. Okay, that's your angle of elevation. Another fun fact, angle of elevation, it is always inside the triangle. Okay, so with angle of elevation, it's always inside the triangle. It's always from the ground up. And if you take a look at this triangle, my right angle would be right here. So my right angle, it's obviously not here because my right angle is going to be there. So the only other possible solution is that my angle of elevation is right there. Okay. So now let's talk about angle of depression. Angle of depression is measured down. It is measured by looking down. Okay. So if you take a look at this picture, this actually is not the triangle that I would draw. The triangle that I would draw would be from the house to directly under the hot air balloon. If I can draw straight, this would be my focal triangle that I would be drawing on my paper. And notice if you take a look at the angle of depression, it's actually not inside your triangle. So angle of depression is never inside the triangle. Not originally inside the triangle. Okay. However, we can actually technically omit this rule because we can use prior knowledge. If this line and this line down here are parallel, and if I'm focusing on this angle, I know this angle is congruent to this angle because of alternate interior angles. But notice this spot right here, I just talked about. This spot right here from the ground up is the angle of elevation. So in reality, the angle of depression and the angle of elevation, the angle of depression and the angle of elevation are the exact same measure. They're not in the necessarily same location, but you can remember that they're in the same location because they are the exact same measure. So a friendly tip, angle of depression equals angle of elevation. So it really doesn't matter whether it's depression or elevation because they're the exact same angle. Remember, angle of elevation is always on the ground. So to keep a nice way to easily remember this is your angle in the word problem is always on the ground. Okay? So let's take a look at an example. Okay? It says Joanna knows that when she stands 134 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 27 degrees. What is the height of the flagpole? So I want to connect Joanna to the top of the flagpole so I can make a right triangle. Okay? So it says Joanna knows she stands 134 feet from the base. So that's here. Okay? And then it says the angle of elevation to the top of the flagpole is 27 degrees. So angle of elevation is always on the ground. So I'm going to put 27 here. And it says, what is the height of the flagpole? Okay. So looking at this problem, you're going to try to do any method you want, but most famously you'd want to start with the Pythagorean theorem. Looking at this triangle right here, do I want to use the Pythagorean theorem? No, because I only have one angle measure. I don't have two angle measures. How about special right triangles? No, because it's not a special right triangle. So I'm stuck. I have to use trig. So this is my reference angle. I'm going to label OAH. So I'm given O and A, so that's tangent. So I'm going to say tangent of 37 degrees, because my degrees always goes with my trig function, equals opposite x over adjacent, which is 134. Alright, so now I have to solve for x. How? Multiply by 134 on both sides. So x is alone. So in my calculator, I'm going to type 134 tan 37, making sure my calculator is in the degree mode, and you should get 68.3. Okay. So therefore, the flagpole is 68.3 feet tall. And I'm done. Okay. These types of problems are not any different than any of the other problems we've done. The only thing that's different is we now have where it says angle of elevation. So you have to remember, no matter if it says angle of elevation or angle of depression, they're the same measure, but they're always on the ground. So let's take a look at the next one. It says Joey is standing at the top of a mountain that is 16 miles from his camp. If the angle of depression is 65 degrees, then how high is the mountain that he's standing on? Alright, so I'm going to connect Joey to his camp, and this is going to drop down, and it's going to form a right angle. Okay, he's standing on the top of a mountain that's 16 miles from his camp. So 16 miles from his camp. And it says the angle of depression is 65 degrees. So let's think about this. Angle of depression would be right here. And if I can actually make that look like 65. So if this angle is 65 degrees, this angle right here is also 65 degrees because alternate interior angles. Okay? So that's another reason to show you how the angle of depression and the angle of elevation just mean the exact same. They're the exact same angle measure. Okay? So you can always assume that they're always going to be on the ground. Alright, so his angle of depression is 65 degrees, and how high is the mountain he's standing on? So I'm looking for x, which is right there. So, alright, I can't use the Pythagorean theorem, can't use special right triangles, so I have to do SOHCAHTOA. So here's my reference angle, label OAH. Which trig function am I using? Tangent. So I'm going to say tangent of 65 degrees. Oops, sorry guys. I do not know what I just pushed. Undo. No! Okay, well let me draw this all again. Sorry. It's not clearly going to look as pretty as my last one. So my angle of depression is on the ground, 65, because it's the same as angle of elevation. I'm looking for how high the mountain is, and it's 16 miles from his camp. So we said O and A, so that's tangent. So tangent of 65 equals x over 16. So now I have to solve for x, so I'm going to multiply by 16 on both sides. My pen's not working here. And I'm going to multiply by 16 over here. So in my calculator, I'm going to type in 16 tan of 65, and I get x equals 34.3. So therefore, the mountain is 34.3 miles tall. Okay, so let's take a look at the next one. Notice the rest of these examples don't have pictures. You have to draw them. That's when this gets a little bit more challenging. Okay, so it says the angle of elevation from the bottom of the lift to the top of the snow bowl is 33 degrees. If the skier rides 1,000 feet on this lift to the top, what is the vertical distance between the bottom of the lift and the top? So, okay, I'm going to ride a ski lift to the top of a mountain. So here's my mountain. If I draw my pretty mountain, here's my ski lift, and it's going to come straight down. Okay. So it says the angle of elevation to the lift, so this is a right triangle, and my angle of elevation is 33 degrees. Angle of elevation is always on the ground. So 33 degrees goes here. So, okay. Skier rides 1,000 feet on this lift. So 1,000 feet is here, because that's the ski lift he rides. I want to know the vertical distance between the bottom of the lift and the top. So the vertical distance is right there. So label OAH. What trig function am I using? Sine. So sine of 33 equals opposite over hypotenuse. So now I am going to solve for x, multiply by 1,000 on both sides. So I get 1,000 sine of 33 equals x. I don't even know why I'm writing that. I'm supposed to be typing that in my calculator. So when I type that in my calculator, I get x equals 544.6 feet. So therefore, the vertical distance is 544.6 feet. Okay. So I want you to go ahead and pause this video. I want you to try angle number 4 and then unpause it, and let's see if you get this right answer. Okay. So it says the angle of depression of an aircraft carrier from an approaching airplane is 52 degrees. If the plane is 700 feet from above the level of the deck of the carrier, how far is the carrier? So, okay. Here's my aircraft carrier. Oops, I need a pen first. Aircraft carrier. And the airplane is 700 feet above the level of the deck. So airplane is here, 700 feet above. How far away is the carrier? If my angle of depression is 52. Angle of depression is the exact same thing as angle of elevation. It can be found on the ground, which is 52 degrees. So this is my reference angle, label OAH. Oh, excuse me. I'm sorry. How far away is the carrier? My X is in the wrong location. I want to know how far my X is from the location, and it's not allowing me to erase that. So I'm going to scribble that out. And I'm going to put X up here, because here's my carrier and here's my airplane. That's the distance. So I'm using sine. So sine of 52 equals 700 over X. So because X is the denominator, I can just switch these two and say X equals 700 divided by sine of 52. And type it into my calculator. I get X equals 888.3 feet. So therefore, the aircraft carrier is 888.3 feet from the airplane. Okay? So I want you to go ahead and try 5 and 6 on your own. And I'll put the answers up here so you have them. And if you need a detailed explanation, you can check the key on Google Classroom. But for 5, you're supposed to get x equals 684.4 meters. And for number 6, you're supposed to get x equals 123.1 meters. Okay. I hope everybody has a great day, and make sure you see me if you have any questions.